Hey everybody, and welcome back. We are going to wrap up our chapter 5 on exponential and logarithmic functions and equations with this last section, section 5.4. And we will be solving equations in this chapter. So go ahead and get your mind in that mindset of solving equations. What does that require? We've been doing that all semester, so the only difference will be solving equations that are logarithmic or exponential. That is our learning target. I can recall and apply all the log and exponential properties when solving equations. So just like I said in our last lesson, everything that we do today, there's not anything new as far as content. We understand what it means to solve an equation. We want to isolate the variable by itself and figure out what it equals. Okay? And we have our list of properties that we have been learning over the course of this chapter as well. Hopefully you already have learned them. If not, then you are going to be behind for today's class. Okay? I will tell you, so that we can get to as many examples as possible, we are going to crank through our practice. This is a recorded video, so you can rewind it or back up at any time. And then if you have any questions, as always, you can pause the video, jot down your questions, and then email me specifics about individual questions. At the end of this, there will be some practice, and you're going to work through those, and then that will be what you email me about in your check-in email as specific examples as well. So to just start us out here, okay, I want us to just kind of get our feet wet. It's been a while since we've maybe solved equations heavily. And so I want to know, what is the first step in solving each of these equations for their missing variable? So starting on the left-hand side, we've got 3 times 2x equals 15. Now, some of us would distribute the 3 and get 6x equals 15, which is totally fine if you did that. And then you would divide by 6 on both sides. That is completely accurate. Okay. Another way that you could go about solving this is to go ahead and get rid of the coefficient by dividing by 3 at the very beginning. And then you're left with this to finish out. Okay. Now, the reason why I'm showing you that is because this is going to be very similar to how we may have to start out solving some equations that are logarithmic and exponential. Case in point, on the right-hand side, you will see instead of 3 times 2x equals 15, you will see 3 times 2 to the x power equals 15. But our first step is going to be the same as it was on the left-hand side. We want to get rid of that coefficient of 3 by dividing it on both sides, which leaves us 2 to the x power equals 5. Okay. And so there's a commonality, and something I want to recall to your memory is that anytime we're solving equations, we always want to deal with that extra material, whether it's a coefficient that you need to multiply or divide away, or whether it is a constant that you need to add or subtract away. But I want you to draw the connection that even though we're dealing with logs and exponential equations today, there's some commonality because we are still solving an equation. Okay? Now these next 2 slides I'm actually adding these to your property sheet. Just so everything is condensed. So if you downloaded that property sheet earlier in the week, you might want to go back to that attachment in Wolfden and re-download it if you want everything all together. I'm trying to do that in hopes that it will be beneficial to you all. Okay. So anytime we are going to solve a logarithmic or an exponential equation, and really any equation at all, our very first step, no matter what, is to always get rid of those constants or those coefficients. Okay? Always, whether we see exponential today or whether we see a logarithmic. If there's a constant or a coefficient that we can get rid of first, that is what we want to do first. I've given you 4 different examples here, so up under that statement. So 2 plus log of 3x equals 4 is our first step there in solving that equation. We will want to subtract 2 on both sides. Okay. That next one, negative 3 plus e to the x minus 2 power equals 1. The first step in solving that equation, we will want to add 3 away on both sides. Okay. This third one, 7 times 12 to the x power. We talked about this a little bit last lesson. 7 is not being raised to the x power. 12 is being raised to the x power. So you could honestly read this as 12 to the x power times 7. Exponents come first, and then multiplication based on our order of operations. So if we were going to solve this equation for that variable x, the first thing that we want to do is get rid of that coefficient of 7 by dividing it away on both sides. And then lastly, we've got 2/3 times the log base 7 of 2x plus 3 equals 31. Again, there's a coefficient, and this time this is a logarithm. There's a coefficient here. Before we try to isolate the variable x, we need to get rid of that coefficient, and the way that we would do that is by multiplying by 3/2 on both sides. Because to get rid of a fraction, we multiply by its reciprocal so that they will end up equaling 1, or canceling out is a layman's term that a lot of people use. Before we go any further, I do want to say that calculators are not allowed for this entire chapter, and so all of your answers must be left in fraction form if possible. I don't want a single decimal for your answer. So if you give me a decimal answer, I'm going to take off points. I'm saying that now. So if you're watching the lesson videos like you're supposed to, you have heard that, you know that. I'm not going to say it again, but I will hold you accountable to it. So fraction answers, please. And now we'll get into the specifics of how to solve exponential equations. Again, one more time, everything that you are about to read to help us solve exponential equations, you should already have learned through your properties. Okay? So I'm not going to spend a lot of time explaining all of this, or at least explaining the properties. I will talk through the process, but I am not talking through the properties, because I have already spent time doing that. If you need some help with that, back up and go to the 5.2 lesson or the 5.3 lesson again. That is why they're recorded, so that you can go back and rewatch them and brush up on that content or that material. Okay. Now, if we are going to solve an exponential equation, there are a couple different approaches or methods that we could take. So the first method, let's say that I give you the equation, and I'll just use that first example. 4 to the x equals 32. Now that should look very familiar to you, because that is actually one of those, or similar to one of your practice problems from our last lesson. So you should technically already know this answer. If not, you can flip back in your notes and find it, but I chose it because you should be familiar with it. But I want you to solve this equation for x. One method that you could take here, and this is the method that you were shown last section, was, can I rewrite both sides of my exponential equation with the same base? Or do they already have the same exponential base? Okay. For this example, I've got 4 as a base to the x power on the left-hand side. On the right-hand side, I've got 32 to the 1 power as a base. Those are not the same. And I cannot rewrite 32 with a base of 4. 4 to the 1 power is 4. 4 squared is 16. 4 cubed is 64. We skip right over 32. So I can't rewrite 32 with a base of 4. So then my next step is, can I rewrite both sides to have the same base? And from last class, you should have discovered that I can rewrite 4 as a base, or with a base of 2 squared, and we're going to hold on to the x. And I can rewrite 32 as 2 to the 5th power. And so again, my goal, my intention is to isolate the variable, but the variable is floating up in the air as an exponent. The only way that I can get to it is if I take a couple different approaches to isolate it. One such approach is this first method of get both sides to have the same base, because that leads us to our property that we learned. When I have an exponential function or an exponential equation, when I have an equation where each side has the same base, I can drop the base and what's left is equal. So 2x equals 5. There's where my answer is coming from, and I've solved the equation. Everything in blue is a property. Everything in black and red is something that we did the last 2 lessons. Okay? It's just knowing that I may have to do that in order to solve an equation. That is the only new thing. The only new thing is applying what you've already learned. So today is much more about trial and error practice than it is, here's all this new content. So hopefully you know it. If not, you need to stop and go back and study those properties. Now you'll notice that there is a second method here. Why do we need a second method? Well, I'll use that example that's under the second method. Let's say I give you 2 to the 2x power equals 6. And you immediately say, okay, this is exponential, so I should be able, or I should try to rewrite both sides to have the same base. Okay? Well, here we go. 2 cannot be rewritten any lower. Okay? 2 to the 1 power is 2, 2 to the second power is 4, da 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 da. I can't get any smaller than that, so that one has to stay. 6, if I try to rewrite 6 with a base of 2, start running through your factors of 2. 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8. So I can't rewrite 6 with a base of 2 raised to a power. It will not work. So the first method is not going to help us out in solving this particular equation. So we need to have a second method or a second option. Here is your second option. Okay, if I can't change the base to be the same, then my second option is, well, what's the inverse of this? Because inverses will, quote, cancel each other out or cause each other to be eliminated to be 1. So I can use the inverse of an exponential to help me get to x. What is the inverse of an exponential function? Okay. It's a logarithmic function. Now we have to be careful here. We learned this last class as well. What is my base of this exponential function? 2 to the 2x power equals 6. My base is 2. So if I'm going to use the inverse of this, the inverse of an exponential function of 2 has to be log base 2. My second method is taking the log on both sides of the equation. So think about it. That's very similar to saying I'm going to take the square root on both sides of the equation, or I'm going to square both sides of the equation. I'm going to subtract 2 on both sides of the equation. We're not doing anything new as far as thinking and solving. The only thing that's a little different is that instead of adding 2 to both sides or squaring both sides, we're going to take the log of both sides. Now you have to be careful because, again, my base is 2, so I have to take the log base 2 of both sides. And so to solve this equation, what I'm looking at is log base 2 of 2 to the 2x power equals log base 2 of 6. And then we are right back with those properties that we've learned in previous classes. I'm still trying to access the x variable. So start with that. Can I simplify that left-hand side? Log base 2 of 2 to the 2x powers. That's a lot of 2's. But one of our properties will tell us, we can either think about it as around the world, so 2 to what power equals 2 to the 2x, or you can remember the property that says if I have a log with a base that is the same as this exponential base, I can drop those two things and what's left is what I keep. The left-hand side is now just 2x, which equals log base 2 of 6. And then all that's left for me to do is solve for x by dividing by 2 on both sides. And my final answer is x equals log base 2 of 6 divided by 2. And I can't simplify that any further, so that's it. I would suggest that you pause the video right now, take some time to go back and look at those properties, maybe rewind and watch this again, because there's really no other way I can explain it other than it is written out for you and you have to study these methods. Okay? So if you are confused, you might want to rewind and watch it again and retry these example problems that I just worked out with you. Now, what happens if I want to solve a logarithmic equation, okay, or a log? We're going to start out the same way. First, I need to get rid of any coefficients or constants, so I need to add or subtract any constants away or multiply or divide any coefficients away. You might even want to try and condense your equation or one side of your equation based on those properties from last class, the product rule, the quotient rule, the power rule. Okay? So you need to decide if you can condense it down, because remember, the more you can condense down, the closer you are getting to access your variable. Okay? So definitely if you can condense it using those power, product, or quotient rules, do that. Then we move into our methods of solving logarithmic equations. So our first method, again, is one of the properties that we learned last class, or the class before that. Okay. Once I have condensed my logarithm down to where there's a single logarithm on the left side of the equation and there's a single logarithm on the right side of the equation, then my first method is to use that common base property. If I've got a log on the left and a log on the right with the same base, then that means I can drop the log base part and what's left is equal. For example, let's say I give you log base 2 of x equals log base 2 of 7. Now that's a very basic problem. We're going to see some that are way more advanced for today's class. But what you have right here in this example is something that has already been all the way condensed down to a single log on the left and a single logarithm on the right, and they have a common or the same base. When they have the same base, I can drop the log base and what's left is what's equal. And in this case, that's my answer, x equals 7. But if it was x plus 5 equals 7, then I would set those equal and solve. Okay. Your second method follows the pattern of your exponential equations. Let me back up to that. Look at your second method when solving exponentials. Okay. Your second method is, if I have an exponential, then I'm going to do the inverse on both sides by taking the log. Well, apply that thinking to a logarithmic equation. If I have a single log on one side and something else on the other side of the equation, I can take the inverse of both sides here as well. What is the inverse of a log? The inverse is the exponential form. Okay? So let's walk through that example that's given to you. Let's say I give you log base 3 of x equals 5. Now, keep in mind, you could do around the world here. You could say 3 to the 5th power equals x, and that would be your answer. If you see that, that's awesome. Do it, because it's really easy. But for the sake of today's lesson, I want to show you the other way as well. When you get to this place and you don't have a log on both sides, like for this example, you don't have a log base 3 term on the right hand side, so you can't use the first method when you don't have a log on both sides. However, you can take the inverse of both sides. What is the inverse of log base 3 of something? The inverse of that would be a base 3 raised to a power. And so for me to get rid of the log base 3 part, I'm going to have to exponentiate, which is just a very fancy way of saying whatever this base is, I'm going to say 3 to all of that as a power, and 3 to all of that as a power. And so it would look, rewritten, it would look like 3 raised to the log base 3 of x power equals 3 to the 5th power. And now I know that looks weird, but think about your properties. When you have an exponent problem, okay, when you have an exponential problem where the base is the same as its logarithm's base, so I have an exponential base of 3 raised to a log with a base of 3. Your power from previously in this chapter says your property from a previous section in this class says I can drop those two things and what is left is what I keep. And that equals 3 to the 5th. Since that's solved for x, that is my final answer. Again, notice that every single thing that I've done was using a combination of properties that we have learned the past 3 class periods. You have to know those properties. All right, I'm not going to say it again because I've already said it 500 times in the last 20 minutes. I think you get it, and if you don't, you'll figure it out very quickly. Know your properties. Okay? Now let's move on and try some examples of this because that's really what today's class is about. It's just practicing. Number 1, I want to solve each equation without using a calculator. I'm going to leave all my answers in fraction form when possible. Number 1 is 36 times 1/3 raised to the 1/5 power equals 4. My first step every single time is to check and see if there's a constant that I can add or subtract away, or if there is a coefficient that I can multiply or divide away. For this example, there is a coefficient that I can get rid of. I want to get rid of the coefficient of 36, and the way that I'm going to get rid of 36 times blah 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 is by dividing 36 away on both sides. Okay. And again, no calculators. So I'm left with 1/3 raised to the 1/5 power, which equals 4/36 is the same thing as 1/9. Now that we have done that, we still are dealing with an exponential equation. We've gotten rid of the constant and coefficients piece. Now we're thinking through, what are my methods? To solve an exponential equation, I've got 2 different options. One option is make the bases the same so that I can drop them and their powers will be equal, or take the log of both sides and solve from there. I would always suggest just starting with the first method, and then if you can't get it to work, move to the second one. The other reason why I would use that first method is because I'm seeing 3 and 9, and I know that 3 squared is equal to 9. So I'm thinking that I can probably rewrite both sides of this equation with the same base. And we did a problem just like this in a previous class where we had to rewrite the bases to be the same. Okay, so I'm going to start with the left-hand side. First thing I want to do is I want to take care of the fractions, because fractions can get very distracting. They can get very busy. So instead of 1 over 3, I want to rewrite this as 3. Okay? But if I'm going to rewrite it as 3, it'll be 3 to the negative 1 power times that 1/5 that I already have. On the right-hand side, I want to get rid of that fraction, so I want to rewrite 1 over 9 as 9 to the negative 1 power. Now, these are not the same base yet, but based on that number sense, based on what I know about these factors and squared numbers, I'm pretty sure that I can rewrite base 9 as a base of 3. So I'm going to walk through that again and just kind of vocalize my thinking process. If I want to rewrite base 9 as a base of 3, let me run through my powers of 3. So 3 to the 1 is 3. 3 squared is 9. So yeah, absolutely, it'll work. Okay, I'm going to rewrite 9 as a base of 3 squared, but I got to keep the negative 1. So all cleaned up, I'll have on the left 3 to the negative 1/5 power equals 3 to the negative 2 power. Based on the properties that we have learned, when the bases are the same, I can drop the bases and the powers are now equal. Okay. And you know what I'm realizing? I'm realizing that there's not a variable in this problem, so I know where it is supposed to be. It's supposed to be x over 5, so my apologies there. X should be x over 5 for each of these. Okay. So that doesn't change our problem. My apologies again then. Okay. Since the bases are the same, I can drop the bases and set the powers equal to each other. So I'll have negative x over 5 equals negative 2. And again, we're doing this without calculators. I need to solve for x. That means the negative 1 over 5 has to go away. And the only way I can get rid of a fraction is by multiplying by its reciprocal on both sides. And so I'm going to multiply by negative 5 over 1 on both sides. And that makes my answer x equals positive 10. Number 2 is also an exponential equation. It's always important for us to think about that first. Like, what am I looking at? I'm looking at an exponential equation. So in the back of my mind, I'm thinking I want to get the exponential bases the same, or I'm going to have to take the inverse side of both sides, which is take the log of both sides. Okay. Number 2 is 20 times 1/2 raised to the x over 3 power, which equals 5. Our first step is to always get rid of the constant or the coefficient if you have one. I do have one, which is 20. I want to divide it away on both sides, leaving me with 1/2 raised to the x over 3 power, which equals 1/4. And now we're kind of looking at the same concept that we did in number 1. My options, my first method, rewrite both sides to have the same base, or take the log of both sides. Well, what I know about my number sense and my squares or my powers of 2 and my powers of 4, I think I can rewrite both sides to have the same base. Okay? I can rewrite 1/2 to be 2 to the negative 1 power times the x over 3 power. And on the right hand side, I can rewrite 4 as 4 to the negative 1 power. If I keep going, clean up the left-hand side, I've got 2 to the negative 1x over 3 power. And on the right, I want to rewrite 4 with a base of 2. Well, I can rewrite 4 as 2 squared, keep the negative 1. So when everything is cleaned up, this is what I'm staring at. Which is good because the bases of my exponential pieces are the same, so I can drop the bases and the powers that are left equal each other. Negative x over 3 equals negative 2. To solve for x, I need to get rid of everything else. So I need to get rid of the negative 1 over 3. And the only way I can do that is by multiplying by its reciprocal on both sides. And x equals positive 6. Number 3, if I read it, it is 4 times e to the 2x power equals 5. Okay. And so as I'm reading that, I'm recognizing that it is an exponential equation, which means, okay, first step is always get rid of the constants or coefficients, but then my two methods are get the bases on either side to be the same or take the log of both sides. Okay. We'll see which one we have to do once we get this cleaned up a little bit more. Okay. I see there's a 4 sitting in front of my base. I want to get rid of that coefficient by dividing 4 away on both sides. And so I have e to the 2x power equals 5/4. On the left-hand side, I've got a base of e raised to a power. On the right-hand side, I've got 5/4, and that's technically raised to the 1 power. Okay. My first method is, can I rewrite both sides to have the same base? Okay. Can you rewrite 5/4 with a base of e? A reminder that e is approximately 2.7. Okay. I don't even know the powers of e. Like, I couldn't tell you off the top of my head what e squared is, or e to the 3rd power. Okay. Likewise, I couldn't tell you off the top of my head what 5/4 to the 7th power is very quickly. Okay. So as we're cranking through and we're looking at both bases on either side and we're thinking through each of their powers, hopefully what is going through your head is this doesn't work. I can't raise e, I can't change my base e to be a base of 5/4 or vice versa. So method 1 is not really going to work here. So we need to shoot for or try for method 2. Method 2 is take the log of both sides, but we have to be very strategic in how we do that. We don't get to just say log on this side and log on that side. We have to be strategic. Okay? Specifically, we've got an exponential piece on one side and then we kind of just have a fraction on the other. So whatever we take the log of both sides on, we need to make sure that it has the same base as e. Now, what type of log has a base of e? A natural log has an understood base of e. So I want to take the natural log base e of both sides. That is our second method. Okay, so if I rewrite all that, I'll have the natural log of e to the 2x power equals the natural log base e of 5/4. Now that looks messier than what we started out with, but remember your properties. When you are taking the log of both sides and you've got an exponential with that same base, look on the left hand side. I've got the natural log base e, and I'm taking that natural log base e of an exponential with a base e. When you are taking the natural log of a base with an exponential of that same base, we can drop that information and just keep that power, or what is left. That is one of our properties that we discussed in a previous lesson. So on the left hand side we've got 2x. On the right hand side, can you drop anything? Can you use a power? Okay. You don't have the natural log base e of e to something, so you can't cancel that out. Nobody in the room knows what e to what power equals 5/4 either, so we can't do that. We really just have to leave that right hand side alone because we don't have a property that justifies changing it. So right now we are sitting with 2x equals the natural log of 5/4. Now if you take a closer look at this is actually a really good thing, because what is the purpose of what we are doing? We are solving each equation for the missing variable. I'm solving for x. Right now I have 2x. How do I get just x? I divide by 2 on both sides. That's the only way I'm going to isolate my variable x. That is a basic skill of solving equations. So on the left hand side I've got x equals. On the right hand side, too many people try to complicate this. They try to make something up that's not there. Do not create something that doesn't exist. You cannot do natural log of 5/4 divided by 2 in your head. If you did it in a calculator, it would be a very messy number. You're not using a calculator, so your final answer is literally the natural log of 5/4. All of that is divided by 2. That is your answer. You can't simplify that any further. You can't just say, oh yeah, that's the natural log of 5/2 because 4 divided by 2 is 2. That doesn't make sense on any plane or any realm of mathematics, so you cannot do that. This is it. This is your answer. Leave it alone and move on to your next problem. Number 4 is 5 to the x plus 2 power plus 3 equals 7. Your first step always is it exponential or logarithmic? It's exponential. Okay. So we're thinking through that mindset. We're thinking about the methods and all of our properties. Okay. And then our first active step is get rid of the constants or coefficients if there are any. We have a constant of positive 3 and we want to get rid of that. So subtract it on both sides. And you're left with 5 to the x plus 2 power equals 4. Now you've got two different methods. Method 1 is rewrite both sides to have the same base, or take the log of both sides. Pause the video and you make the decision. What do you think you should do? Powers of 5. 5 to the 1 is 5. 5 squared is 25. That won't work. Powers of 4. 4 to the 1 is 4. 4 squared is 16. That doesn't work either. I cannot rewrite 5 or 4 to have a common base. And so when I cannot rewrite both sides to have the same base, my only other option is to take the log of both sides. But I have to be careful. I can't just say the log of both sides and be done. What is my base on this exponential equation? My base is 5. So when I take the log of both sides, I'm going to be doing log base 5 of both sides. Okay. Rewrite that so that you can see everything. Log base 5 of 5 to the x plus 2 power equals log base 5 of 4. Based on our properties that we have learned, this log base and this exponential base are the same. I can cancel them out, leaving me with the power, which equals the right-hand side. The right-hand side I cannot cancel out. I have no property that lets me simplify log base 5 of 4, so it has to stay. I want to solve for x. The way that I'm going to do that is isolate x, subtract 2 on both sides. You need to be very careful here as well. That's why this example is built into your notes. This will be x equals log base 5. This will not be log base 5 of 2. No, 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 no. This is one term, like your squirt bottle. This is a completely separate term, like your marker. You cannot add a squirt bottle and a marker together and get 2 markers. Just like you cannot add a log to a constant. It does not work. They have to remain separate. So this will have to be log base 5 of 4. My suggestion would be to put the minus 2 up front. Because here's what's going to happen. On your online test, some of you are going to put this, and I'm going to mark it wrong. Okay. All right. Or I may not mark that wrong, but some of you may put this, and that is 100% wrong. That is not it. Okay. So my suggestion would be to just put that constant out front, or maybe put some parentheses around your 4 and then do a minus 2. That way you know that they do not go together. Okay, bottom line, you cannot combine a log term with a constant term. It does not work. The only way you can combine a log with anything is using a property of a logarithm. Okay. Number 5, which is the last one on this slide. We've got about 4 more for today's class, and then I'm going to have some for you to practice. Okay. But number 5 looks different from all the others up above it. Okay. It is different because on the left-hand side, I have given you 2 log terms to deal with. Now, I want you to think about what you wrote down in your notes for solving logarithmic equations. Your first step is always get rid of the constant or the coefficient. Your second step was condense it down to a single log term if possible. And so what we need to try to do before anything else now, take care of any constants, which there aren't any for this one. Second, we need to try and condense this down to 1 log term. So that left-hand side, we want to try and condense that into a single log. Okay? So that is our first step for this problem. Before we go any further, the only way we can condense this down using our properties is if our logs have the same base. Does log of 4 and log of x plus 3 have the same base? Yes, they do. They both have a base of 10. And so what property allows me to condense 2 logs with the same base with addition? Okay. This would be the quotient rule. So I can rewrite that whole entire side as the log base 10 of 4 times x plus 3. Okay. And if you want, you can even go ahead and distribute that. You can either go ahead and say that this is the log base 10 of 4x plus 12, which equals 2. Okay. Now you have some options here. You can either do the around the world method, okay, where you can say 10 to the second power equals this. That would probably be what I do, just because I like that process. I use that a lot, and so it makes sense for me to do that, and I can immediately solve the equation. Or you can think about the specific methods that were written out for you at the beginning of this lesson. Okay. If I don't have a log on both sides of the equation, my first method is out. So my second method is exponentiate both sides. Okay. And I have to exponentiate very carefully, meaning raise everything to a power. Okay. But what will be the base of my exponentiating? Okay. Well, what is the base of my logarithm? The base of my logarithm is 10. So that means when I exponentiate, I'm exponentiating both sides by 10. And so this will become 10 to the log base 10 of 4x plus 12, which equals 10 squared. And here we are again back at some of those same properties. I have an exponential base that is the same as a log base. I can cancel those out, leaving me, cancel out loosely, I can drop those, leaving me with 4x plus 12. And that equals 10 squared, which is 100. Subtract 12 on both sides. Divide by 4 on both sides. And x equals 22. Number 6 is 3 times the natural log of x equals 11. What type of equation are we dealing with right now? We have transitioned, or we have started working through some logarithmic equations. So again, first step is to get rid of the constants or the coefficients. Second, if I have to or if I need to, condense each side down to a single log. And then I've got my two methods. Okay. I either have each side with a common base for each log, or I exponentiate on both sides. I've been telling you that there's several different ways that you can go about solving these, and so I want to show you both of these ways before we go any further. Okay, on the left-hand side, I'm going to keep doing what we've been doing, okay, which is, are there constants or coefficients to get rid of? Yes, there are. I need to get rid of that 3. The only way I can get rid of 3 times something is if I divide by 3 on both sides. And so I have the natural log of x equals 11 thirds. Okay. Since I don't have a log on both sides of the equation, my next or my second method is to exponentiate both sides. What is the base of my log? That's what I'm exponentiating by on both sides. So e to the natural log of x power equals e to the 11 thirds power. Base are the same, they can be dropped. X equals e to the 11 thirds. And that would be your final answer. Now the other way that you could do this is by relying on some of those other properties or rules that you have learned. Okay? The left-hand side is not the only way that you could do this. Okay? Some of you may have seen that 3 out front of that log or that natural log, and you might have said, I can pull that backwards and that can be a power. I can rewrite this as the natural log of x cubed equals 11. Okay? And then maybe some of you, okay, so notice how those are we're pretty close to the same step here. Okay? Some of you might have looked at this and said, well, the base is e to the 11th power equals x cubed. And maybe you went with your answer like that, okay? I wouldn't necessarily recommend doing it that way because you'll end up with something like this. E to the 11th power equals x cubed. And then you'll have to take the cubic root on both sides, which would not be pleasant in the slightest, okay? But you could do it. You can take the cubic root on both sides. Okay. This would leave you x on this side. Remember, the cubic root is the same thing as the 1/3 power, and so this would still end up being e to the 11 over, or 11 times the 1/3 power. Okay. So you would still end up with this same answer, but I'm not telling you that one method is equally easy as the other. The left-hand side, to me, is much easier to do than the right-hand side. But that is just a judgment call that you're going to have to make problem by problem. Number 7 is also a logarithmic equation. Log base 6 of 2x plus 5, all of that is a part of that logarithm, equals log base 6 of 17. Okay. So, first step, are there any constants or coefficients sitting in front of the log or off to the side? If so, we need to get rid of them. Okay. And there aren't any. Okay, do I need to condense the left-hand side into a single logarithm? No, it's already a single logarithm. What about the right-hand side? It's also a single logarithm, so I don't need to condense anything. So then method 1 says this: if I have an equation where each side of the equation is a single log with the same base, drop the log part and what's inside, or what's left, is equal. Okay. Do I have an equation where each side of the equation is a log with the same base? On the left-hand side, I have log base 6. On the right-hand side, I have log base 6. I have a perfect example of method 1 in solving logarithmic equations. I have the same log base on both sides, so I can drop the log base part and keep everything else. 2x plus 5 equals 17. And then all you have to do is solve that equation for x. Subtract 5 from both sides. Divide by 2 on both sides. Final answer, x equals 6. Our last example that we will look at and do together is number 8. Okay. Make sure you got plenty of space for this one because it's going to require a little bit of extra work. Okay. I'm going to be all over the screen here just because it's going to take up a good bit of space. Actually, I'm going to see if I can move this up a little bit. I've got the natural log of 3x minus 2 plus the natural log of x minus 1 equals 2 natural log of x. Now, there is a lot of stuff going on in this problem. First thing to ask yourself, is this a logarithmic or exponential? It's logarithmic. Okay. Second thing to ask yourself, are there constants or coefficients that I need to get rid of? Is there a 2 times the natural log somewhere? Is there a natural log of blah, 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 and then a plus a number or a minus a number? Okay. What I see is I see a 2 times the natural log of x. However, if I try to divide that on both sides, look what happens. I just end up creating a mess on the left-hand side. I end up creating a division coefficient or a 1/2 coefficient that I would then want to get rid of to move back to the other side. So for this specific problem, that option is not really going to work well for us. Okay, so we're back to the drawing board. We're not really seeing any coefficients or constants that'll work for us. Okay, so then move to your second option. or your second little check-off box. Okay? Can you condense the left-hand side into a single log? Can you condense the right-hand side to a single log? Okay. You can absolutely condense on this logarithm. How do I know that? Because on the left-hand side, I've got two natural logs, which means they both have a base of 3. If I have two logs with the same base, I can condense them, or I can apply my list of properties to them. And so that is what I want to do first on this problem. I want to condense the left-hand side. What property says I can condense two logarithms with the same base through addition? Okay. That would be the product rule. I can condense this down to the natural log of 3x minus 2 times x minus 1. I can condense all of that into one logarithm. And on the right hand side, I've got 2 to the natural log of x. Okay. Now another thing that I see is on the right hand side, we've already looked at that, is 2 natural log of x. And so we already attempted to divide by 2 on both sides, and we saw that that wasn't going to help our cause. It was going to make it more confusing and more cluttered. So think about something else. Do we have a property of logarithms that says if you've got a coefficient out front, I can move that? Okay. That would be your power rule. I can take that 2 and move it back to be a power of x. Okay. So that's going to be my next move. I'm going to keep everything else the same for now. And on the right hand side, I'm going to rewrite that as the natural log of x squared. Now look at what you have. Do you have a single logarithm on both sides of the equation? I've got the natural log of blank times blank on the left. Check. On the right hand side, I've got the natural log of x squared. Check. When I have a single log on either side of the equation and they have the same base, natural logs always have a base of e. When that happens by one of my properties of logarithms, I can drop the natural log and keep everything else. I can keep the 3x minus 2 times the x minus 1 equals, and I keep the x squared. Now we have completely eliminated the logarithm portion of this. Now all we have to do is solve for the variable x. Q multiplying binomials, you like to call it foiling. Q factoring, quadratic formula, those things are coming right back into play. You cannot forget about them. They are fair game. And for us to solve this equation for x, that's exactly what we're going to have to do. So on the left-hand side, we're going to have to multiply those binomials. 3x times x is 3x squared, times 3x times negative 1 is negative 3x. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. On the right-hand side, I've got x squared. Combine your like terms, clean it up just a little bit. 3x squared minus 5x plus 2 equals x squared. Okay. And what we learned at the very beginning of our course was when we are trying to solve a quadratic equation like this algebraically, we've got to get it set equal to 0. Okay? And the only way that we can get this to be equal to 0 is if we subtract the x squared on both sides. So now we are staring at 2x squared minus 5x plus 2 equals 0. And that, ladies and gentlemen, leads you to either factoring or solving this problem by factoring or solving using the quadratic formula. Go ahead and pause this video and do your factoring or your quadratic formula, and we will reconvene in just a few moments. So whether you did the quadratic formula or whether you factored or solved by factoring, you should get your solutions to be 1/2 and +2. However, and this is the part that you are not going to like me for, but I didn't make the rules, someone else did. Don't shoot the messenger. Especially when you end up with multiple solutions with a logarithmic function or equation, you have got to check to make sure that both solutions work. Here is why you have to do that. Let me take you back to this right here. You have been reading this statement for several class periods now. It's how we introduced exponentials and logarithms, how the base has to be greater than 0 and it can equal 1. Okay. Same thing with a logarithm. I can't take the log of certain things. Okay. I can't take the log, regardless of base, I can't take the log of a number less than or equal to 0. It's like I can't take the log of 0. If you tried to do that in your calculator, you would get an error. Okay. I can't take the log of -1. It will not work. It's not a real solution. Now I can take the log of 0.5. It's a really nasty decimal number, but I can do it. But I cannot take the logarithm of 0 or less. And so that brings me back to this problem. You are going to have to go back and check to see which of these work. Both of them may work. Neither one of them may work. You have to check. Okay? We have to plug in each of these solutions and make sure that they are going to work. Remember, we cannot take the log of 0 or less. Okay? So we can't take the log of 0, we can't take the log of a negative number, is basically what I'm saying. So let's go and let's test 1/2 first. I'm going to do the natural log of 3 times 1/2 minus 2 plus the natural log of 1/2 minus 1 equals, or it should equal, 2 natural log of 1/2. Okay? And again, keep in mind, you're doing all this without a calculator. This is by far the hardest problem that I could give you, so you can't expect for me to give you a lot of these because it takes a long time. You still need to know this content, which is why I'm walking through it with you. Okay? So here we go. Okay? The natural log of 3 times 1/2 is 3/2, or you can think of it as 1.5. What is 1.5 or 3/2 minus 2? Hopefully all of you are thinking that's a negative number. That's -1/2 or -0.5. Can I take the log of a negative number? Absolutely not. So what does that tell you about the solution 1/2? It doesn't work. You got to throw it out. After all that work, you have to throw out one of your solutions. Okay? It's not pleasant. It's not the most fun thing in the world, but we got to do it. Okay? Now let's check our other solution, because we would hate to just skip right on over and get this problem wrong after we spend all this time working on it. Okay? So now I've got the natural log of 3 times 2 minus 2 plus the natural log of 2 minus 1 equals, or it better equal, 2 times the natural log of 2. Okay, so here we go. The natural log of, what is 3 times 2? That's 6. Minus 2 is 4. Plus the natural log of, what is 2 minus 1? 1. Can I take the natural log of 1? Yeah, absolutely. Okay, and that equals 2 log 2. Can I take the log of 4? Yes, I can. Can I take the log of 1? Sure. Can I take the log of 2? Yes. Okay. So what does that tell us about our answer of x equals 2? It is a solution. It works. Okay. So all of that work to find that one solution of x equals 2. Okay. You can expect at max one of those on your test. And notice there's a lot of work to be done on that problem, but that also means there's a lot of potential partial credit to be earned for that problem. So I don't want you to be scared about that. I want you to try your practice problems that are on the next page. At least one of those is going to be similar to that last one where there's 2 possible solutions and you've got to check it. Okay. But ultimately, I want you to pause the video and I want you to work through these 9 practice. There's basically one comparable problem to each one that we did in class. So you should have a really good idea of if you understand what you're doing or not. Okay. I am only going to put the answers here. I'm not going to show any work. But I do want you to work through these because it's going to tell you if you know what you're doing or not. Okay. And then if you don't know what you're doing, then next class during our test review will be a great time for us to Zoom and ask those questions and figure out what we can do to best prepare. I can already tell you the best prep is to learn your properties. And if you don't know your properties, you're not going to be successful. Okay. So learn those. If you don't know them and you can't spout them off to me when I ask you what are your properties, then that's going to be my response. You don't know what you're doing because you don't know your properties, and that'll be our first step. Okay. Pause the video, try these 9, and then make sure to send me your check-in email. Have a good one, people.